Alright guys, welcome to lesson 10.4. We have two objectives today. We are going to continue our work with radians. Today I'm going to give you the graph of an angle, and our job is going to be to calculate it. We've done it before with angles. We're just, last time we did it with degrees, but now we're going to do it with radians. Then we're going to also review the Pythagorean Theorem. That'll come in handy quite a few times. Why don't we go ahead and start off with the Pythagorean Theorem today, and then we'll move on to the angle stuff at the end. So, Pythagorean Theorem, something you guys might want to write down is that it only applies to right triangles. And a right triangle is, as you know, a triangle with an angle that's 90 degrees. Now, the side that's across from that is called the hypotenuse. Right? It also happens to be the longest side on a right triangle. Okay? So I'm going to call this leg A, I'm going to call this leg B, and the hypotenuse C. And interestingly enough, the lengths of these sides always have this relationship over here, where if you square one leg and add it to the square of another leg, it should always equal to the square of the hypotenuse. So what's important is that you understand that it doesn't matter where A and B go, but it matters very much that in this spot over here, that's the hypotenuse. So when you're plugging these numbers in, you want to make sure you put the hypotenuse where the C is located. Okay? So let's go ahead and take a look at a couple of examples here. So we'll go ahead and call this example 1 here for today. So we have a right triangle, and there's two sides that are given. We have this side and this side. It's important to identify which of the sides on this triangle are the hypotenuse. And so this side here is the hypotenuse. So when we plug it into our formula here, a squared plus b squared equals c squared, it is important to recognize that that 13 will be going in where the c is at. The other two numbers that we have up there are 8 and then the unknown number, which is x. So it doesn't really matter where you put those in the equation. They could be flip-flopped, so you could write it as x squared plus 8 squared, or you could write it as 8 squared plus x squared. It doesn't really matter. You'll get the same answer either way. But once again, what is important is that that 13 goes over here on this side because it is the hypotenuse. From here, we're just going to go ahead and solve it out. We get 64 here and 169 here. The next step is to just get that x by itself, so we'll subtract, which leaves us with 501, and then we're going to go ahead and take the square root. And we end up with the square root of 105. Now typically when you solve an equation by taking a square root, you get a plus and a minus. But in this case, we don't, because we're doing geometry. And with geometry, negative answers don't make sense. You can't say that this side over here is negative 105, so we won't include the negative possibility. Another thing that we want to keep in mind is that sometimes you'll need to break down these square roots. This one, however, I don't think it's going to break down. Let me try it real quick. You don't have to write this because it may or may not break down. Let me see. So it turns into 5, 3, and 7. And when we're taking a square root, we're looking for pairs of identical numbers, and there are none. So in this case, we can just leave our answer as the square root of 105 because the square root does not simplify. There's no pairs to take out. All right, so that's one example. Let's go ahead and take a look at another one here. I'm going to call this example 1 still, like the last one would be part A. This will be part B, right? But we're still calling this example 1. Let's do another one here. So how would we do our setup here? We're going to have a squared plus b squared equals c squared. So what goes where? I would encourage you guys to think a moment about where I'm going to put these numbers. So hopefully you're recognizing which one is the hypotenuse. This is the hypotenuse. How do I know that? Because it's the longest side and because it's the side that's across from the 90-degree angle there. And that means that's the one that goes here. The other two sides, it doesn't matter where you put them, so long as they go in the other two blanks somewhere. All right? And so we have 64 and we have 100. And we add these up, and we get 164. And then we're going to go ahead and take a square root. And we don't have to worry about the negative once again because we're doing geometry. Now this one I'm thinking will simplify, so let's go ahead and see how that one breaks apart there. I've got 164. That's going to break apart into, I know 4 goes in there, 41 times. Maybe that one doesn't break apart. 41 seems like a prime number. Oh, okay, I missed something. I forgot that the 4 breaks down again, right? So that's 2 and 2. So we have the square root of 2 times 41. And we have a pair of 2, so I can take the 2 out. And therefore, the final answer is going to be 2 square root of 41. So if you can simplify the square root, you should. All right, I got one more example I'd like to do with you guys before I give you a practice. Each one of these has a little something different. And this one, what's different about it is that one of the legs already have a square root on it. Not a big deal, though. We'll show you how it works out. Which one is the hypotenuse? Hopefully you recognize it's the 8. And the other 2 can just go right on in here. Now, this is 64. This is x squared. This guy, the square cancels out the root, so you're just left with 37, basically. Now, sometimes you'll have another number in the front here, like let's say I had like a 5 here. Well, the 2 would still make that become just a 37, but it would also square the 5 to make 25, so you'd have 25 times 37. Now, we don't have that here. I'm just mentioning to you, sometimes you will have a number in the front like that, but I don't, so it just ends up canceling out the root, and I'm just left with 37. So let's go ahead and solve for x now. Now I know that 27 is 3 times 3 times 3, and so a 3 can come out, right? And so my final answer here will be 3 radical 3 for the other leg on that right triangle. All right, so I'm going to go ahead and let you guys practice a couple of these at this time. Got 3 problems for you here, numbers 4, 5, and 6. So go ahead and pause the video here, give it a try, and when you unpause it, you will see the solutions. All right, so there you go. Number 4, square root of 161. Number 5 is 2. And number 5 is the square root of 7. All right, let's go ahead and move on to take a look at our second objective today. So, which is we want to be finding the measures of angles, but this time in radians. So before we begin this, if you want to write this in your notes, it could be helpful. As you guys may recall, when we're doing degrees, this is 0. Up here is 90. This is 180, and this is this is 270, and then over here is also 360, right? But when we're talking about radians, this is 0. This is pi over 2, and this is pi. And I think that's going to be good enough. And here's what I want you guys to be aware of here, is that anytime you have this much of a turn, you know, just a quarter turn, that's pi over 2. And anytime you have this much of a turn, in other words, half of a full circle, that's going to be pi. Okay? Now, if I don't know if we're going to get to see these. I think we might get to see some where we go all the way around today. If you ever see one of those, that's a 2 pi. Okay? So, something to keep in mind before we begin is that a quarter turn, represented in green here, is pi over 2. A half turn, halfway around, is pi. And a full turn, all the way around the circle, is 2 pi. Okay? That might be something to keep in mind. Be helpful for our problems today. All right, let's go ahead and take a look at number 1. I'm going to call this example 2 on the notes. Okay? So I'm going to do 2 parts for this example. So let's go ahead and take a look at this first part. Now, I want to find the measure of this red arc, so I'm going from here to here, and after that we're going a little bit further to here. Okay? And our question is, how much is this angle? Well, we know that this pink part is a half turn, and so that pink part is pi radians. It's a half of a circle, and that's equal to pi. Next, we have this little green part here, which they tell us is 5/18 pi's. So we're adding to that 5 pi over 18. All right, so the trick for the problems today is that in order to be able to add these together, we're going to need to create some common denominators. So I'm going to think of this pi here as pi over 1. And I have to ask myself now, what's the common denominator for 1 and 18 there? And hopefully you guys know that that's 18. So I'm going to multiply the top and the bottom here by 18. And this one's already 18, so I can leave it alone. And so I end up with 18 pi over 18 plus 5 pi over 18. And once you get that common denominator, you can just combine the numerators together. 18 and 5 makes 23 pi over 18. That would be our final answer. So you have to find the measurements of your pieces and add them together. And in that process, you're going to need to get a common denominator. Let's take a look at a second problem here for example 2. Let's take a look at this one. All right, so for this guy here, we're going from here to here. Now that's a quarter turn, which you guys know at this point is pi over 2. Next, we have a little bit more right here, but you'll notice that I don't know what that is. They didn't tell me what that piece is, and that happens. So I need to figure out how much is this piece over here. Put a question mark there for now. Well, we have to find the missing piece just like we did before. So before I go any further, I'm going to actually erase what I've done so far, and I'm going to start over here at the beginning to think, before I begin, let's find the missing piece. Well, as you guys know, from here to here is a quarter circle, and that's pi over 2, right? Now, pi over 2, in this case, is going to be pi over 3 plus something. Okay, so I want to know what is my something. Well, to do that, I need to subtract both sides by pi over 3. So over here, that's gone. And now I've got pi over 2 minus pi over 3. And in order to subtract those, I'm going to need to get a common denominator here. So what's the common denominator for 2 and 3? Well, it would be 6. So I'm going to multiply this one by 3 on the top and bottom in order to get 6 on the bottom. And for this guy over here, I'm going to multiply the top and the bottom by 2 in order to get that common denominator. As a result, that's going to give me 3 pi over 6 minus 2 pi over 6, which is equal to 3 take away 2 is 1 pi over 6. So I'll just put pi over 6. And that's my missing piece. That's the question mark that I have right here. Okay, so let me get rid of all that. So the first step that we need to do is we need to find the missing piece. Okay, we had pi over 3 here. I don't know what this is, but I do know that if you add these together, you get pi over 2. So I set that up and I solved for my missing piece, and I got pi over 6. So let's go ahead and fill that in there first. Now that I've got that filled in, now I can actually go back and solve the problem they're asking me for. So I want to find out what's the measure of this red arc here. So from here to here is pi over 2, which we said earlier. And then we're going to add to that this little piece over here, which we now know to be pi over 6. Okay, so if I want to add these together, I need to get a common denominator. So what's the common denominator for 2 and 6? Okay, hopefully you know it is 6. So I'm going to multiply the top and the bottom of this one here by 3. It's going to give me 3 pi over 6 plus pi over 6. Now pi over 6, that's a 1 pi over 6 if you're confused. Pi just means 1 pi. So now we can add these together and we get 4 pi over 6. And of course you do want to reduce if possible. 4 over 6 does reduce to 2 pi over 3 would be our final answer there. So we did problems like this before with degrees. Remember, if we had this angle here, we would just subtract it from 90 to find the missing piece. Well, this time the difference is that we're subtracting it from pi over 2. It's a little more complicated because you need to get common denominators. But after you find that missing piece, then you can go ahead and just go through the process of adding together the pieces to get your final answer. All right. So we'll go ahead and toss one of these at you guys here. We're going to go ahead and bump up here to number 3. And we're going to call this one Student Practice 2. So go ahead and pause the video here and see if you guys can find the measure of this red arc. Now keep in mind it is going clockwise, which means it's negative. But go ahead and see if you guys can find the measure of that angle there. When you unpause the video, you will see the solution. All right, so the solution here is boxed in. It's 7 pi over 6. So let's see, how did we get there? Well, first of all, we need to find this missing piece here. Once again, from here to here is pi over 2. So we know that pi over 2 is equal to this one plus this one. In other words, we have this equation here. Pi over 2 is equal to pi over 3 plus our missing piece. Now this is the same equation we had in the last slide actually. So if you just subtract the pi over 3 to the other side, you'll have to get a common denominator. But really didn't need to do the work because like I said, we've already done this one on the last page. We find out that missing piece is pi over 6. So now we know that right here is pi over 6. Now for the rest of the problem, we know that going from here to here is pi. So that's why I've got pi there. And we also know that going from here to here is pi over 6. After that, we get our common denominator by changing the pi into 6 pi over 6. And then adding those together with 7 pi over 6. And I just remembered this is supposed to come out negative, right? Because it is a negative angle, so it's supposed to be negative 7 pi over 6. All right, so that is Student Practice 2. Let's go ahead and take a look at another example here. I'm going to go ahead and call this one Example 3. It's not a whole lot different than the ones we just did. There is a slight difference. In this case, notice that the part that they're giving me is bigger than 1 quadrant, okay? And what I really want to find is I want to find out what's this missing piece here. Well, in a case like this, you can't do anything with pi over 2 because from here to here is pi over 2, but this goes beyond that. So that's a little bit difficult to find. But what we do know is that well, not a full circle, but a half circle is pi, right? So here's what I know then. I know that this piece plus this piece should add up to pi, a full half circle. So pi should be equal to the green part added to my missing part. Oops. Okay. From there, we're just got to solve for our missing part. It's going to be 2 pi over 3. So I've got pi minus 2 pi over 3. And once again, we need to find our common denominator because right now it's over 1, right? So I'm going to multiply the top and the bottom by 3 to get a common denominator. So I've got 3 pi over 3 minus 2 pi over 3. Combining these numerators, 3 pi minus 2 pi is 1 pi over 3. There's my final answer there. So this missing piece would be pi over 3. Okay. So sometimes the piece that you need to find, you're not going to get it by adding it with something to make pi over 2. Sometimes you're going to find it by adding it with something to make pi, because in this case, the given piece was bigger than pi over 2. All right, so let's give you guys one like that here. Go ahead and try number 5 and see how you guys do with that one. And when you unpause the video, you'll see the solution. So the answer there is 29 pi over 18. Now, you'll notice that I didn't find the missing piece, and the reason why is because you don't need to. On this one, we're only going from here to here, which is pi, and here to here, which they already gave us, which is 11 pi over 18. So I didn't need to find this missing piece, but if you did want to go about finding that missing piece, it would have been 7 pi over 18. But even if you went through the trouble of finding it, you may have come to the conclusion, oh, I didn't really need to find it this time, because the missing piece was not part of our red arc here. So let's go ahead and move on to another example. We'll go ahead and call this one here example 4, I guess. I think that's where we're at now. All right, so here we go. Now, I don't think I'm going to need to find my missing piece here because I see I've got this, which is a full circle. That's 2 pi. And then I've got this, which is a half circle, which is 2 pi. I'm sorry, 1 pi. And then after that, we have this little extra piece that's left over, which they actually just gave me. So I don't need to find any missing pieces here. Every piece that I need, I can easily calculate myself. And so, well, not calculate myself, I can easily just look at to know what it is. So there's our answer. We have 2 pi plus pi over 6. Okay? So we need a common denominator. Now, before I do the common denominator, I'm going to go ahead and put these two together because they already are kind of like terms here. So putting 2 pi with 1 pi, I get 3 pi. After that, I'm going to go ahead and get a common denominator. So currently, this is over 1, so I want to multiply it by 6 on the top and bottom, which is going to give me 18 pi over 6 plus pi over 6, which is 19 pi over 6. Okay. Let's go ahead and jump up to student practice number 4. Now for you guys, you will have to find the missing piece on this one. Okay. You notice that we have a full circle, we have a half circle, and then we've got this, but we don't know what that piece is. So you're going to need to find out what that missing piece is, and I'll leave it to you guys to see if you can figure it out. So go ahead and pause the video here and see if you guys can find the measure of this angle, and when you unpause it, you will see the solution. So the missing piece, the green portion over here, would be pi over 3. How do we know that? Because from here to here should be equal to pi over 2. And so we have pi over 6 plus my missing piece should make pi over 2, and that's where this equation here comes from. And then minusing pi over 6 on both sides gives us this. After you get a common denominator and subtract, you should have ended up with pi over 3. So my missing piece here was pi over 3. Now that we have that, we're ready to go ahead and find the measure of the red arc. So this red portion here is a full circle, 2 pi. The blue portion here is a half circle, which is pi. And the green part, the missing piece that we found, we decided was pi over 3. So from there, putting the 2 pi and the 1 pi, we get 3 pi. Getting a common denominator for these and adding them together, we get our final answer, 10 pi over 3. All right, let's go ahead and take a look at one more example before we call it a day here. We'll call this one here example 5. All right, so do I need to find the missing piece? I don't think I do. I'm looking at this and I see that we have a full circle here, which I know is 2 pi. We have another full circle here, which is another 2 pi. And then finally we have this portion here, which is given to me. They tell me that this whole part right here is 5 pi over 6. So basically I have 2 pi as orange. That's the orange circle. I've also got another 2 pi from the green circle here. That's another full circle. And then for the pink portion here, we have given to us is 5 pi over 6. So we just need to add all 3 of those together, and we will be done. So putting these together first, because they already match, is 4 pi. Now we need a common denominator, so put that over 1, multiply the top and the bottom by 6, and I get 24 pi over 6 plus 5 pi over 6, which is 29 pi over 6. All right. But you will notice that we are going in a clockwise direction, right? And so that is a negative 29 pi over 6. All right. So I got lucky on this one. Once again, I did not need to find that missing piece. We'll see how you guys do on yours. Let's take a look here and have you guys go ahead and find the answer to number 9. When you unpause the video, we'll show you the solution, and that'll be it. This is student practice number 5. All right, so your final answer should have been negative 10 pi over 3. So how is that the case? You guys may have noticed that on yours you do need to find that missing piece once again. We know that from here to here is 2 pi over 3, and we know that the whole half of this right here is pi. So I know that 2 pi over 3 plus that missing piece should add up to a half circle, which is pi. Okay, so I'm going to go ahead and minus the 2 pi over 3 on both sides. And in order to subtract those, we're going to need a common denominator. So I'll put that over 1, and I'll multiply the top and the bottom by 3. So I end up with 3 pi over 3 minus 2 pi over 3, which is going to end up being 1 pi over 3. All right. So over here, we know now this portion, this missing piece, from here to here, is pi over 3. So I'll go ahead and mark that somehow. Let's go ahead and make it pink. We'll call that pi over 3. All right. Now we're ready to go ahead and find the measure of our angle. So we know that from here to, I'll use a different color so it doesn't match the pink there. From here to here, that's a full circle. And then from here to here is a half circle. And then finally, from here to here is the missing piece that we found. So we have a full circle, which is 2 pi. We have a half circle, which is pi. And then we have the missing piece that we found, which is pi over 3. We just got to add all those pieces together, and we'll be good to go. 2 pi and 1 pi makes 3 pi. Putting that over 1 and getting a common denominator, get 9 pi over 3. Which adds up to 10 pi over 3. But we do want to recall that we are going in a clockwise direction, and therefore this is negative 10 pi over 3. All right, so that does it for our lesson today. We found missing sides of a right triangle using Pythagorean's theorem first, and then we jumped back and we did some calculation of angles, of radians, and that's it. So hopefully that was helpful, and we'll see you guys in class.